Students, this is question number 8 and we need a figure for this. So let me draw the figure. So we got a circle. Okay. And we need to draw the axis. So we've got the x-axis and the y-axis, and then over here you have a line. So this is the line AB. Now the question wants us to find the coordinate. So this is the question given x negative 2 the whole squared positive y squared is equal to 8 as the equation of the circle. Now we have to find the coordinates of A and B. Okay, that's the first part. So we'll start with the first part, then we'll gravitate towards the second part. So clearly, if you see, for coordinate A, it's on the y-axis. So that means the x-coordinate is going to be 0. So A is on the y-axis. So this means x is equal to 0. So therefore, I take this as 1. 1 is rewritten as 0 negative 2 whole squared positive y squared is equal to 8. Which means this is 4 units. So y squared is equal to 8 negative 4. So y squared is equal to 4. Therefore y is equal to root of 4. And you will have plus 2 and minus 2. But we need only plus 2. So y is equal to 2. Now the coordinates of A. So therefore A coordinate is 0, 2. For B, we put y is equal to 2 in 1. Okay. So this is going to be x minus 2 the whole squared positive 2 squared is equal to 8. 2 squared is 4. So this is 8. So x negative 2 the whole squared is equal to 4. You take the root there. So this means x negative 2 is equal to root of 4. This means I need only the positive part, right? So this is going to be 2. You move to the other side, you get x is equal to 4. So therefore the coordinate for B is 4, 2. So we have got the B's coordinate, we have got the A's coordinate. So that's one part of the question. Now we have the next part. For the next part, let me just write the question for you. Okay, find the volume of revolution of the shaded region bounded by circle and the chord AB. Okay, the rotation is about x-axis. So I have placed the question. So that means we are interested in this region, right? Now circle, we know the equation of the circle. Now we need to extract the equation of the circle for y. So this is what we have got. So y squared is equal to 8 negative x negative 2 the whole squared. So that will be the equation of the circle. Now we need to get the chord, right? Now this is actually y is equal to 2 with y being equal to 2. So that would be the region for our integration. So let me move on. So required volume of integration, I'm going to write the formula. Required volume is equal to, you can write it as volume of integration or just simply say required volume is equal to pi times integral. So this is the equation of the curve. So y squared curve minus the line, right, with reference to dx. And the region of integration, the bounds would be above the x-axis, right? So above the x-axis it is going to be 0 to 4. So that would be the required region. So this can be rewritten as integral 0 to 4. As I mentioned to you, we have already got the curve 8 negative, let me write that, 8 negative of x negative 2 the whole squared, right? We need to just place the y squared value. That is followed by y is equal to 2 here. So that means equal to 4 because of the value being y squared, right? So this would be the region, and we will have to evaluate this. So if I were to evaluate this, I can rewrite this as pi times integral 0 to 4 8 into dx negative integral 0 to 4 x negative 2 the whole square dx negative integral 4 times the dx, right? These two can be clubbed and rewritten as pi times integral 0 to 4, so 4 times dx negative integral 0 to 4 x negative 2 the whole squared times dx. Now this can be easily be integrated. Now for this I'm just going to say consider integral 0 to 4 x negative 2 the whole squared times dx. Let x negative 2 be equal to some u, so dx is equal to du. So don't worry about the integration, just substitute and integrate. This is u raised to the power of 3 over 3, but u is x negative 2, right? X negative 2, this is cubed divided by 3, and now you place the limits. Limits are 0 to 4, so you place the upper limit, you get 4 negative 2, that's going to be 2 raised to the power of 3, right, divided by 3, negative 0, this is going to be 8 over 3, right? So apparently when you substitute the upper limit you're getting 2, so that's 8 over 3. Negative, when you substitute 0 you are getting negative 2 raised to the power of 3, that's negative 8, but apparently there are two negatives, so this is going to be positive. So you sum it up, you get 8 plus 8, that's 16 over 3 will be the value for this integral. So this is pi times of 4, when you integrate this you get 4 x, substitute the upper limit, right, you get 4 times of x 0 to 4 negative, already I've shown you how to get this. This is 16 over 3, you substitute the upper limit, you get 4, lower limit is 0, no use of substituting that, so you have a pi there, so this is 16 over 3. Now this can be rewritten as pi times 4 into 4 is 16 negative 16 over 3. Now if you take the LCM as 3, this would be 48 negative 16, and you have a pi there, and this would give you, when you subtract this, would give you 32. So 32 pi over 3 cubic units, right? Cubic units. So this is the required volume. Okay.